Hello, I thought I'd take this time to revisit Module 3 with data files. It seems like that's a little bit of a challenging topic for some, so hopefully this will help. So I'll read through the material a little bit here, which I've done in the past, and then we'll spend most of the time actually working through a couple examples. So again, Module 3 centers on reading and writing files, basically two different languages, three different ways, so or three different file types. So the basic idea here is that your intent is at the end of this experience to be able to read and write text, XML, and binary files in both Python and R. Most of the data you'll get and will produce will be in files as a general rule. That is especially true in both the big data world and in the advanced analytics and machine learning world. So as a data scientist, it's something that's very important to know how to do. Oftentimes file processing is an important part of what we have to do inside of machine learning and data science. So the texts are pretty good. You can also search for more directed data around a particular topic if you're so inclined. Lots of different ways you can read files in Python, lots of different formats, reading the various sorts of data, be it a CSV, an HTML, and so on. And then there's also a lower level sort of thing of reading directly from the file. Your basic idea whenever you're dealing with a file is that you both open it, and in this case you typically call read, and then you'll oftentimes take that thing you're reading and do something with it. Sometimes there's an intermediate step. Sometimes you read it and then write it right away. Fairly common thing to do. It is important to understand the concept of scoping whenever you're doing this so that you know how it works. XML, talked a lot about that in the past. It's a fairly well discussed topic. Also, frankly, you don't see it as much anymore, so I'll move right along. XML has somewhat been replaced by things like JSON, primarily because JSON is much smaller. Lots of stuff to know about XML. I've talked about it ad nauseum, so the solution I showed here utilizes this concept of an XPath to extract nodes of interest, and also a way to basically convert it into a dictionary of dictionaries. Lots of different ways to do this stuff. The reality is, though, XML is kind of fading away. You'll still see it because there's lots of legacy systems out there that produce it or consume it. But it is kind of bloated is the problem compared to something like JSON. Significant difference in file size. So because of that, we'll oftentimes stay away from it and just simply not use it because it is quite large. With that, I'm going to go ahead and shift over. Again, reviewing, don't use try except for flow control. Bad things happen when you do. R makes it a little bit easier in some ways, I think, because they have some decent libraries out there already. So what I'll do right now is shift over and share my screen here. Some things are still kind of going on, so I'm in a new environment and I'm having to get various things installed, and what I'm doing right now is making sure that everything is actually working, and it looks like it is, so good. I created a new environment inside of my Anaconda installation, primarily so that it was easier for me to show both R and Python inside of a Jupyter Notebook a little bit cleaner. So jumping straight in, we'll talk about doing basic file I/O inside of Python. So the thing that you'll see on the screen here is where I was doing the pip installs inside of a notebook. You only need to do that once per environment. Better ways to do it, but I was in a hurry, so I went and took some shortcuts. I'm going to go ahead and clear the kernel and clear all the output so that it's you can see that there's no no smoke and mirrors going on here. So what this basically does is an example of setting up all of the inputs and the outputs of the three different types, and this is for just Python, that are necessary for this assignment. And the idea here, and let me see how big that is because I may need to make it a little bigger. Let's see if we can get rid of some stuff here. So get rid of this, and can we go bigger? That's pretty big. So hopefully that's easier to read. So the idea here is that you have a series of pip installs that basically you got to have some libraries in place so you can actually do some of this stuff. Pandas, Matplotlib, those are fairly common. sklearn, pretty common. NLTK, Natural Language Toolkit, less common. You probably aren't using that too much. But it is something that's used in this example. So basically we import all these various things in, and one of the things this assignment or the submission does is produce a word cloud. So we basically are specifying the name of the folder that things live in, and then we're joining together using ospath.join that input folder with the various things that are either going to be written to or read from. And so to make sure again that there are no tricks going on, I'll go through and clear out the output folder because it does have stuff in it right now because I have ran this before. So the first thing we do is basically set up those variables, and that's all this is doing is essentially creating. It's taking a little bit of time there because it had to, the kernel was restarted, so I had to kind of get its context. Then the next thing is to do text, and text processing, as we talked about, text is just a text file. In this case, we're reading a file called example jfkey_moon.txt, the speech from Kennedy, and to see it here, essentially the text of that speech, and so the idea then is to read that in and then do some stuff with it. So in this case, using an open to get back a file, and then we're doing a read to read it in, and then an output file doing an open as well, but we're telling it that we want it to be able to write to that. So you pass in that second parameter to say what kind of opening it is. It defaults to read. If you want to actually produce something you want to do write, you may be producing something later on down here that you need binary. So you want to say that you want write binary, and this is going to say read binary. So when we open up the binary file, you specify that as well. It just so happens that you don't really have to say read because it's kind of assumed it's the default sort of thing. So basically what this does is uses a tokenizer. Tokenizer is a thing that converts a stream of characters and words into a set of tokens, in simplistic terms, words, but it's a little more general of a concept because in some programming languages you have tokenizers that tokenize constructs within a programming language, and in that situation yes, they're words, but they're words with specific types of meaning and syntax, so slightly different, but we do use the word token. And the idea here is to utilize a regular expression to get just those things that we kind of really want. So we only want alphabet characters inside of our tokens, and that's exactly what this is doing. Then we're looking for something of a certain length, so we only want reasonably long tokens. And so we take all those, and if all that stuff passes, we add it to a list, and then we return that list back whenever we're done. So this goes through and says get the remaining tokens, and what it's doing is you're using this text that you read up here. Given that we did a read, we probably could have actually went ahead and closed the file at that point, but it doesn't hurt anyway. Understand that from here until here, that file is open and being read. Read only, probably not as big of a deal. Write, you oftentimes try to minimize the amount of time that you have a write file open, although in this situation you couldn't have really waited much. So what this is basically doing is taking this stream that was read, tokenizing it, and then taking those words and then listing through those words, writing them out to that file that we're producing, one word per line, /n is going to be a new line, and then close it. And literally that's what it is. And then this next step is to go through and produce a word cloud using these same words that have been tokenized, and basically just writing it out. So I'll go ahead and run this so you can see it in action. There's our word cloud, and also at the point that ran, it produced this output, and we can see here now for some reason XML went to, I'm not sure quite why that happened, but we did produce our text file. So this is the input. Sorry, I didn't do that. This is the output, and here's the output that was produced, and it's a series of words. This is sort of a bag of words, but not quite, because if it were truly, then it would be ordered with accounts associated with them. Sorry for the interruption. So back again. Going through the output is, like I mentioned, this is close to being a bag of words, but it's not quite, because for one, it's not necessarily sorted. It doesn't have the count. So, but it does show you that the output was being produced from this code. Went through and also produced the word cloud using that same list of words. So it's kind of a little bit of a value add there. Again, if you were to do something like this, make sure you make it your own, and make sure that you do some additional error handling and checking, because this isn't doing very much at all. So here's the example of doing binary, and what this is doing is taking a file that's specified by bin input and writing it out to bin output, doing read and write attributes as well. So these are the file handles. We open them up, we do a read, a byte at a time, and then while we've got something, and this is a pattern you'll see again, you take that and write it to a list, and then at the end we're going to take that list and then for each one write it out. This is loading everything into a list a byte at a time, and then writing it out a byte at a time. Probably not the most efficient, but it does demonstrate the required rubric here. Also, though, do make sure that if you were to do this, that you do some additional error handling, checking, and so on. And you can check, we can see here that it did produce this binary file, which is a JPEG. Then the last example here is around using XML. We talked about XML a different sort of way, or a variation of it. This is kind of a similar concept. It's using the XML's entity tree, or element tree, sorry, parsing. So basically we're using ET's element tree's parse to parse the file. Then using that essentially object model, we get the root, and then we take ourself and iterate through the root, looking at each of the items, assuming that they are a book, and then we construct a dictionary for each one of those books. We set some default values. We look for them using a .find, and if we do find it, we save the text into the various fields, and then we populate our dictionary. Then we append that dictionary to a list of dictionaries, and then create a pandas data frame from it, and then potentially see here, I think we're going to write that out at the very end, or we certainly could if we're not, so it doesn't look like it is here. So basically we're taking this data frame, going through each of the rows, making sure everything is a string, and then setting some values, again constructing a bit of our own little XML tree, and then writing it back out. So taking it, tearing it apart, putting it back together. So when we run that, we'll see that output as well here, and you can see it basically is doing what I'm saying, is they're putting it back together. Equally well, it might have been interesting, and it could be interesting, we'll go ahead and do it, to save that data frame, and I'll use that, or this, plus .csv. And so with that, we've written it out. I just used the file name because it had the complete path, but we can see here that is what the data frame looks like. We've got our index, we've got the book ID, the title, the author, the price, or the published date, the price, and then a description. So not a very large file, but does get across the point. And again, if you were doing this, you might want to do something a little bit more interesting, although the assignment does say 1 kilobyte, right? So it is more than 1K. So that's one thing to take a look at. So our next experience should be going over and taking a look at the R version of that as well. So that's kind of half of it, but this is it's not done, right? So this is showing you kind of a high-level thing. It would be good to review the rubric and make sure that you're doing things like handling errors, doing some, if not handling the errors, doing some inspection. Some of this would be a little challenging because it's this is the only thing you might could do is check to see if maybe the links are appropriate at the end of the experience or something. And XML, again, it's kind of challenging too. But you want to do a little bit of data exploration or analysis or something to kind of show that you know that your data is in a good shape. So now looking at R file input and output, same sort of concept, but this time in R. And I am running inside of Jupyter with the R kernel. You can see up here this is R, and it knows that it is R. I'm going to go ahead and trust the notebook, even though it's not really doing anything terribly interesting. So the first thing is kind of similar to what we did in the previous Python example. We set up our path of where we're reading things from, and then we've got the files that we're using to read those. And so we set that up, and then to move into the text processing example. So the basic idea here is similar to what we did before. You're going to have some stop words, which are words that you want to remove because they're kind of noisy. And then here this is combining together very much similar to what the IO path is doing, combining together the input directory that we know up here with the name of the file, and then saying that we want it to be a read-only file, and then for the write file we say that we want it to be write, and then the similar sort of logic. This is doing it a line at a time. So the key concept here with any of these sort of loop-based processing approaches is that you read the first line. Generally there's a while loop, and then you loop until you don't get anything with the read that happens at the very last instruction of your loop. This is a very common pattern. You'll see it all the time. So that is how this is historically done. And then at the very end we're doing some closes. Better ways that this might have been done would be to whenever we're opening up those files, make sure that they truly close with some sort of exception handling if you can do that in R. So anyway, back to the assignment at hand. So that's basically doing what we just wanted, and we can go over and take a look. Again, I'll clean up the outputs, although it is coming across with R JFK process.txt, and you can see it's a little different behavior this time because of the logic is different, because we are reading the lines and then kind of writing things pretty much in a kind of a cleansed way together. Moving on to the binary, same sort of concept. You open up a file, read while you've got stuff, read it the first time, and then keep reading until you run out of stuff, and then write it back out. And then once you're done, close the file handles. And then the last example here is around XML. Similar sort of approach as what I've talked about in the past, but this is using kind of the equivalent of the dot notation. So I'll go ahead and run this, and then we'll talk through it. And it is giving you a few warnings because there is potentially a NA being introduced because of coercion. So if things aren't present and so on, and there also may be XML document that is empty as well. So walking through what this code is doing, we start off by essentially doing the equivalent of an import. We're saying we want to use XML and we want to use methods. And then we combine together the input path and the XML file names to produce the appropriate name for the files. And then we load the XML into a data frame. Using XML to data frame, we see how many rows there are and how many columns. Ideally, you would have something that embodies this inside of the code. So something that says, hey, there should be 12 rows and 6 columns. and then once we've got those elements, we start going through, and we set off by saying, essentially, create, work our way through this new XML data that we're creating by setting an author attribute with the author that is essentially a valid author, and then if it's not, then you would have invalid author, the same sort of concept below as well, saying there is no author. And then moving on to title, same sort of logic, two different things together, and then moving on, and this is basically just doing nothing more than if it is NA, then make it be a prettier string than NA. So probably a cleaner way to do that, but this is functional. And then once you get past all of the kind of error handling and cleansing, then it's a matter of just basically going through and doing some looping and getting the values that you're looking for. And then at the end of it all, we save the XML off. So that is, in a nutshell, kind of the behaviors. This is one implementation. Lots of different ways you can solve these problems, some better than others. Those are kind of bare minimums. It's a good idea to include documentation in your code, both if you're using Jupyter. It's a great way to do it. If you're not using Jupyter, just put it inside of your code itself. Another example of using this is a different way of doing XML. This is the way that I've shown you in the past, which is basically utilizing essentially in a lot of ways simplistic, but it doesn't have as much error handling, and it's also not necessarily writing something out. This is just reading, right? So to do this completely, you would need to also take, rather than just printing out the results, probably would be a good idea to actually save them off in some format. And you could definitely do something where perhaps you read something in a XML and write it to a text file, or if you know how, read something from a text file, if you know the structure of the file is what I mean by how, and write it out as an XML file. You probably don't want to do something like that with images, because it gets really, binary stuff gets tricky pretty quickly. I'll go ahead and save that and close it. And one of the things I have talked about, I touched on it briefly, but to show the concept, one of the things that can help improve the quality of your deliverables is to include some examples, so or some documentation. So in this case, and then we can set that to Markdown. And when you do that, it suddenly looks nice, right? Markdown is a topic unto itself, and you'll notice in my history I've been there several times. There are some subtleties to it, and subtle differences as well. One of the things that I was playing with is a table, and it works pretty well most of the time, but your syntax is pretty ugly, right? This is what it looks like. But there may be times if you wanted to include something like a table, you always make sure you have to go in and just switch it over and say that it is Markdown, and you can see that it does do what you would want it to do. Not necessarily the prettiest thing you'll ever see, but it is sufficient for what you probably need. Go crazy here and try something that probably won't work. Yeah, you can see it didn't interpret that. So basically what that's telling you at the top is that this is the column, and this is telling it that it is a column heading, that it should be treated specially. So again, lots of things to do with Markdown. You can do the common sort of things, such as the headings, which I've shown, and this is showing you the various heading levels, similar to an HTML H1s through H6s. Also, you can utilize this double the equal sign underneath of the text, or underlines to do it as well. You don't do that as much. Generally speaking, you'll use this, partly because of the influence Python has had. Also, you'll generally want a space after the pound sign. That's an important thing that oftentimes you forget. Then paragraphs, pretty easy. It just kind of does what you would think it would do. Line breaks, you pretty much just need to do what you would think, but a carriage return. Bold, a little less obvious. You can do star star or underscore excuse me, underscore at the beginning and end, and you can see that it does both those. And so the star is probably the more common approach, 2 stars together. Italics, single star. So a little bit clunky, but the idea of Markdown is a very simple sort of set of controls that you can master pretty quickly, but don't require any kind of special encoding. So if you use 3 stars, then you're getting a bold and in italic. Probably want to avoid it a lot of the time because it will get pretty clunky. And then block quotes, again, it's a little bit of a weird sort of thing. A caret, greater than, to move things over. You can nest them as well with greater than, and so on. I'm not sure how much you'd do with a quote with most code things, but you could. So those are kind of the key things. Lists, kind of what you would think if you just make a normal list, and it will actually kind of do the right thing. You can do a 1 to indicate that it should be numbered. It really doesn't look at the numbers. It just knows that it's an ordered list, and so it'll treat it that way. You can also do unordered list with just a dash or a star, a plus or a minus, and you can nest them as well. So important stuff to understand. And then you, generally speaking, you don't mix your list together, items and so on. And code blocks you might use as an example, but generally speaking, we don't use them too much. It is possible to embed images as well, so you can go and if you use this sort of syntax, so it's kind of a little odd, right? And probably that is the hover. That's not showing a hover. That's the alternative text, I would assume, and this is the actual image location. I have used that to embed animated GIFs because it is a way of making a notebook much more interesting if you're trying to show how to do something, especially. And that's a lot of Markdown. Horizontal rules, same sort of concept. Just by itself, 3 stars or whatever, 3 dashes or 3 underscores by themselves will do a horizontal rule. The rendering is going to be the same. It's going to be this horizontal line. And so with that, it's kind of the basic concepts inside of the Markdown. So with that, I will start wrapping this up. Thank you for joining and watching. This has been a good course. Most of you have done very, very well. If you have questions, be pretty quick about getting them to me, because we're near the end of this experience. I'll do what I can to respond as quickly as possible, and I'll also do my best to turn around your grading very quickly on the off chance that you do need to make some revisions. It's problematic, though, if you give me something the day it's due and there are some issues. So do make sure that you attempt every assignment if you haven't already. If you don't complete one of the assignments, it doesn't matter how well you do on everything else, you can't pass. So do keep that in mind. And also feel free to connect with me on LinkedIn if you're so inclined. Don't feel any pressure to do so. I'm going to be around. I'll be teaching other courses here at Rasmussen as well. So stay in touch and stay safe. do let me know what I can do to help those of you who aren't quite finished to wrap this up. We want you to succeed and do well in the course. So if there's something I can do that can help you, let me know. I'm perfectly willing to do whatever it takes. I want you to succeed. I hate seeing students not do well. It really concerns me. So let me know if there's something I can do to help. Stay safe as always, and I'll see you in future courses.